Hi everyone, welcome back. In this video, I'm going to build something that brings together two data concepts I think are really useful to understand in practice: medallion architecture and entity resolution. We'll do the whole thing in Microsoft Fabric. We'll start with some deliberately messy CSV files and move them through bronze, silver, and gold until we have clean, usable data feeding a Power BI dashboard. Then we'll make the problem a little harder. I'll bring in a second system with no shared customer ID and use entity resolution to work out which records actually refer to the same person. And once everything is working, I'll step back and compare the experience with Databricks because although the two platforms overlap quite a lot, they approach some of these problems very differently. So there's quite a bit to cover. But before we start building, let me quickly explain the two main ideas so the rest of the demo has some context. Let's start with medallion architecture. The idea is actually quite simple. Instead of trying to take messy source data and clean, transform, and prepare everything in one big step, we move it progressively through three layers: bronze, silver, and gold. Bronze is the raw layer. This is where I want to preserve the data more or less exactly as it arrived. Duplicates stay. Bad dates stay. Odd formatting stays. And that's intentional, because if I later discover that my transformation logic was wrong, I can always come back to bronze and start again from the original source. So bronze is really about preservation and traceability. Then we move into silver. This is where the data starts becoming trustworthy. We convert data types, standardize formats, remove duplicates, and validate important fields. But there's one principle I want to follow throughout this demo. Bad data doesn't automatically mean deleted data. If something is wrong, I'd rather flag it clearly and preserve it than make it silently disappear. Then finally, we have gold. Gold is where we shape the data around whoever is actually going to use it. That might be a dashboard, an analytical model, another application, or some downstream process. So a simple way of thinking about the three layers is: bronze preserves what arrived, silver improves and validates it, gold makes it useful, and that silver layer becomes particularly important for the second part of the demo. That second part is entity resolution. Imagine I have a CRM system over here and a case management system over here. They were built separately. They use completely different identifiers. There's no common customer ID that I can simply join on, but some of the people appearing in those systems are actually the same people. So how do we work that out? That's the problem entity resolution is designed to solve, and there are really a few stages involved. First, we standardize the data. Names are a good example. The same name can appear with different casing, punctuation, spacing, or even a different word order. So before comparing anything, we try to remove those superficial differences. Then we create a short list of possible matches. At scale, we don't want to compare every person with every other person. That becomes expensive very quickly. So we use some relatively simple signals. Maybe the same date of birth, the same email address, or names that sound similar to identify pairs that are worth investigating. Then we score those candidates. How similar are the names? Do the dates of birth agree? Do the emails match? And then comes the most important part: the decision. Is this a confident match? Is it close enough that a human should review it? Or is it simply not a match? And this is where entity resolution really earns your trust. The goal isn't to match as many records as possible. The goal is to create matches that you can actually defend. Once we've made those decisions, we can create a golden record, one consolidated representation of the person while still keeping track of the original source records. And finally, we need to make that result useful. So I'll also build a simple search capability that can be called outside the notebook. Later in the demo, I'll show you a particularly useful example where two names look very similar, but the evidence tells us they should stay as two different people. That's the kind of case where entity resolution becomes much more than just fuzzy matching. But before we get there, let's look at the data we're actually going to use. I'm using three small CSV files. The first is customers with 11 rows. The second is transactions with 16 rows. And the third is contacts with 8 rows. We won't need contacts until the entity resolution section. The data sets are small on purpose. That way we can actually follow individual records as they move through the pipeline instead of trying to work out what changed among thousands of rows. And I've deliberately introduced several problems into the data. One customer appears twice with identical details, so we have a straightforward duplicate. Dates appear in two different formats in the same column. Some use year, month, day. Others use the Australian day, month, year format. And one date is completely invalid. There's also a broken email address. In the transactions file, one transaction references a customer that doesn't exist. So we have an orphaned record. There are negative and missing transaction amounts as well. And finally, in the contacts file, some of the same people appear with their names written differently. Different word order, different formatting, and in some cases, slightly different spelling. None of these problems are random. I've put each one there specifically so we can see what happens to it later. Some will be cleaned, some will be flagged, some will be excluded from reporting, and some will become part of our entity resolution logic. So now that we know what we're dealing with, let's move into Fabric and build it. Fabric expects an organizational Microsoft identity. So normally, you'll sign in with a work or school-style Microsoft account rather than a standard personal Gmail or Outlook account. If you already have one, that's the easiest route. Just sign into Fabric. From the Account menu, I can start the Fabric trial, choose a region, and activate it. And for most people with an organizational account, that's really all there is to it. If you only have a personal account but already have access to an Azure tenant, there's another option. Inside Microsoft Entra ID, I can create an organizational user. That gives me a new username and a temporary password. Then I can sign into Fabric using that account and activate the trial in exactly the same way. Whichever path you use, we eventually arrive at the same place. And from here onward, everything is the same. The first thing I'll create is a workspace. I think of the workspace as the container for the solution. Our lakehouse, notebooks, Power BI model, and functions can all live together here. Inside that workspace, I'll create a lakehouse called POC. This is going to hold all of our data. Bronze, silver, and gold aren't three separate platforms. They're simply different logical layers within the same lakehouse. And one of the things you notice fairly quickly with Fabric is how much of the underlying setup is already packaged into the platform. I haven't created a separate storage account. I haven't configured a separate connection between Spark and storage. For a proof of concept like this, that lets us get from an empty workspace to actually working with data fairly quickly. Now I'm going to create a folder in the workspace to keep all of our notebooks together. There's just one Spark setting I want to change before we start. For this demo, I'm switching to Runtime 2.0. That gives us some useful behavior later when we need to deal with malformed dates safely. Let's create our first notebook, 01 Medallion. This is where we'll build the bronze, silver, and gold layers. The first thing I need to do is add a data source. In our case, that's the POC lakehouse we created earlier. This allows the notebook to run code directly against the data and tables in that lakehouse. The first cell is just a little bit of setup. I'm importing the Spark functions we'll need later. Next, I need to create 3 schemas, one for each layer of the Medallion architecture. I can do that by running these SQL commands. Or, if you prefer, you can use the Fabric interface and create each schema manually, one at a time. So the architecture we saw in the diagram now has a physical structure inside the lakehouse. Now we can start moving some data through it. I'll create a landing area and upload the 3 files we looked at earlier. And I'll quickly check that everything landed correctly. All 3 are there. So now we can start with bronze. Bronze is intentionally simple. I read the source file. I add a couple of useful metadata columns, the file name it came from, and the time it was ingested. And then I save it as a bronze table. That's essentially it. No cleaning, no filtering, no deduplication, and I'm deliberately keeping the source values as text rather than trying to interpret too much too early. At this stage, I'm interested in one thing: what actually arrived? If I open the raw customer table, you can see the duplicate straight away. Both copies are still there, and the birth date is still stored as text. Nobody has tried to fix anything yet. That's exactly what I want from bronze. Whatever happens further down the pipeline, I still have the original version available if I ever need to go back. Now we can start improving it. Next, we move into the silver layer, where we'll start addressing the data quality issues we identified earlier. The first problem is dates. As we saw earlier, this column contains two different formats. So rather than assuming everything follows one format, I've created a small helper that tries them safely in sequence. First, it tries the standard format. If that doesn't work, it tries the Australian day-month-year format. And if neither one produces a valid date, we return null. So if somebody gives us something impossible, like the 31st of February, the pipeline doesn't crash. But it also doesn't guess. It simply says, we couldn't confidently interpret this value. That's a much safer outcome. Now we can use that logic in Silver. A few things happen here. I standardize the names. I parse the dates using the helper we just created. I deduplicate the customers and keep the most recent version. And then I add two simple quality flags. Is the email valid? And does this customer have a usable date of birth? Those flags allow us to separate two decisions. First, is there a problem? And second, what should we do about it? They don't have to happen at the same stage. For example, this customer has an invalid email address, and this one has an unusable birth date. But notice that both records are still here. They haven't been deleted. The problem has simply been made visible, so anyone looking at Silver later can see exactly what happened. And then Gold can decide how those values should actually be presented to users. We'll do the same thing with transactions. First, I make sure the amount is actually numeric. If it contains something invalid, it becomes null instead of breaking the whole pipeline. Then I remove duplicate transactions, and after that, I check whether every transaction references a customer that actually exists. If it doesn't, I flag it. The same applies to negative or missing amounts. So again, the data stays available. We're not making the problem disappear. We're making it explicit. And once we have those quality indicators, we can make more deliberate decisions in Gold. Gold is where I start thinking less about the source and more about the consumer. For example, a dashboard may not need somebody's full date of birth. It may only need an age group. So here I derive three categories: under 30, 30 to 49, and 50 plus. This is also where those Silver quality flags start having a practical effect. If an email address failed validation, I don't expose it in Gold. The original value is still available in Silver, so nothing has been lost. We're simply presenting a cleaner and safer version for consumption. We do the same thing with transactions. This Gold table aggregates monthly spending by channel, but only transactions that meet our quality requirements contribute to the calculation. Unknown customer, excluded. Invalid amount, excluded. Unusable date, excluded. But again, those transactions haven't disappeared from the platform. They simply aren't trusted enough to participate in this particular business view. So if someone later asks, why doesn't this total match the original source? I can go straight back to Silver and show them exactly which transactions were excluded and why. That's much easier to audit and explain than burying those rules inside a report. And now that our Gold layer is ready, we can take it into Power BI. I'll create a semantic model using our two Gold tables. Then I define the relationship between customers and transactions. Once that exists, Power BI understands how those two data sets connect. And because the preparation has already happened upstream, the reporting model itself stays relatively simple. From here, I can build a quick dashboard: spend by state, a trend over time by channel, top customers, and a filter for state or age group. It's a fairly standard dashboard, and that's actually what I want. Because the important thing is what isn't happening here. There's no data cleaning inside this report, no formula repairing broken dates, no visual filter trying to hide bad transactions, no workaround to compensate for duplicates. All of that happened once, upstream. So if a business rule changes, I change it in the pipeline. I don't have to hunt through several dashboards trying to work out where someone implemented a slightly different version of the same rule. And that's one of the practical strengths of this architecture. The data layer deals with data quality. The reporting layer deals with reporting. And now that we have clean, standardized data, we're in a much better position to tackle entity resolution. I'll create a second notebook called 02 Entity Resolution and attach the same lakehouse. Fabric notebooks have their own execution context, so I need to initialize a little bit of the setup again. But the important part is that our data is already sitting in the lakehouse. Now we can bring in the third source. The contacts file represents something like a case management system. And this system has absolutely no knowledge of our CRM. Different IDs, different source system, no shared customer key. If that shared key existed, this would just be a normal join. The fact that it doesn't is exactly why we need entity resolution. Before trying to match anything, I run the contacts data through the same bronze and silver pattern. And there's a useful architectural point here. We don't need a completely different data process just because we've added another source. We preserve the original in bronze. We standardize and validate it in silver. Then we use the cleaned result downstream. Once both sources are in a reasonably consistent form, we can start comparing them. The first challenge is names. Names are surprisingly messy across systems. Different casing, different punctuation, extra spaces, different word order. So before comparing names, I normalize them. I remove anything that isn't a letter. I split the name into words, I sort those words, and then I join them back together. That means two names containing the same components in a different order can end up with the same standardized representation. Now, that doesn't prove they're the same person. It simply removes some of the noise before we start matching. Next, I take the fields we care about from both systems, name, date of birth, email, and state, and put them into the same structure. From this point onward, the matching logic doesn't really care which source the record came from. Structurally, they now look the same. And that brings us to candidate generation. There are two main things happening here. The first is candidate generation, sometimes called blocking. With a tiny data set like this, I technically could compare everything with everything. But at real scale, that becomes expensive very quickly. So instead, I build a shortlist. Two records become candidates if they share an email address, share a date of birth, or have names that sound similar. And this is important. Being a candidate does not mean being a match. It simply means these two are similar enough that we should take a closer look. Then we score those candidates. How similar are the names? Do the dates of birth match? Do the emails line up? And then I apply some deliberately conservative decision rules. Same email? Very strong evidence. Same date of birth plus a sufficiently similar name? Also a confident match. Extremely similar name, but not enough supporting evidence? That becomes a review case. And weak or contradictory evidence? No match. So the similarity score gives us evidence. The decision rules determine whether that evidence is actually strong enough. Let's look at a few examples. Show exact email match. This first one is straightforward. Same email address. Strong evidence, so we classify it as a match. This next one is much more interesting. The names sound similar enough that the records passed our candidate generation stage, so the system was right to investigate them. But then we look at the rest of the evidence. The dates of birth don't match, and the overall name similarity isn't strong enough. So the final result is no match. And this is exactly the type of behavior I want. A simple fuzzy name algorithm might have merged these people. Our process makes an important distinction between these records look similar and we have enough evidence to say they're the same person. Those are very different things. And here we have another case. This record has no date of birth, so we simply don't have enough supporting evidence. Rather than forcing an answer, the system leaves it unresolved. And I actually think that's a very important characteristic of a good entity resolution system. Being uncertain is fine. Being confidently wrong is much more dangerous. Once we have our confident matches, we can start creating actual entity identities. For this demo, I'm using the CRM as the anchor. If a contact confidently matches an existing CRM customer, they share the same entity ID. If it doesn't safely match anyone, it becomes its own entity. For two source systems, that gives us a simple and understandable approach. If we had 5 or 10 systems, we'd probably start looking at something more sophisticated, such as clustering or graph-based entity resolution. Now, we can create the final golden record. And that term can be a little misleading. We're not choosing one system and throwing everything else away. What we're doing is creating one usable representation of a person while still preserving where the information came from. So in this example, I might prefer the CRM version of the name, but I also retain the associated email addresses and references to all of the source records behind that person. That gives us one consolidated identity without losing provenance. Now we can look at the final result. We started with 10 customers and 8 contacts, so 18 source records. After entity resolution, we end up with 13 distinct entities. And that number tells us quite a lot. If we still had 18, nothing would have matched. If we ended up with 10, we'd probably be forcing every contact onto an existing customer, whether the evidence supported it or not. Instead, we land somewhere in between. Where this count is 2, we've successfully linked records across both systems. Where it's 1, that record stays separate because there wasn't enough evidence to merge it safely. And that's exactly what we want. The goal isn't to maximize the number of matches, it's to maximize defensible matches. To make the result easier to use, I've added a simple search function over the golden record table. If I search for a common surname, we can see both kinds of outcomes. Here's someone successfully linked across both systems. And here's another similar-looking person who remains separate because the evidence wasn't strong enough. And that really captures the whole entity resolution idea in one result. Confident merges where the evidence supports them, and honest, unresolved cases where it doesn't. But right now, this search only works because I'm inside the notebook. So let's make it usable outside Fabric as well. For that, I'm going to use a Fabric user data function. We need a user data function here because the search logic currently only runs inside the notebook, and we want to make it available outside Fabric notebooks. You can think of a user data function as taking a small piece of Python logic and turning it into something another application or workflow can call. That means I can expose this search capability without having to build and maintain a separate application server. First, in the workspace, I create a new user data functions item called search entity. Before writing any code, I connect it to our data source, which in this case is the POC Lakehouse. Then I write the function itself, and once it's ready, publish it so it can be called outside the notebook. There is one small trade-off here. Some of the richer information I can return easily inside the notebook, such as the complete set of contributing source records, is less convenient to expose through this interface. So the published function gives us the core information needed for a search, while the richer detail stays in the lakehouse. And now I can run the same search from a completely new notebook without needing any of the context or setup from the notebook where we originally built the function. So let's create a new notebook. To use our entity resolution capability, I simply retrieve the published function from the registry, pass in a search term, and run it. That's very convenient because the underlying logic is packaged once and can then be reused from other notebooks or applications without rebuilding it each time. So we've taken something that started as notebook logic and turned it into a reusable capability. And that completes the entity resolution build. Now that we've built the whole workflow in Fabric, I want to step back for a moment. Because if you're evaluating Fabric, there's a good chance Databricks is somewhere in the same conversation. And rather than just comparing feature lists, I think there's a more useful question. How does this kind of workload actually fit on each platform? The first thing to say is that Fabric and Databricks have more in common than you might expect. Both support lakehouse-style architectures. Both work well with bronze, silver, and gold patterns. Both support open data formats. And both give you Spark for the core engineering workload. So if you know PySpark, much of the transformation logic we've just written feels very familiar on either platform. That's actually good news. It means the engineering pattern itself is portable. Where the experience starts to differ is in the platform around that code. Take the bronze ingestion step we built earlier. Read the file, preserve the source, add lineage metadata, write the table. Databricks fits naturally around that kind of notebook-driven engineering workflow. Fabric can do the same thing in notebooks, as we've just seen. But Fabric also gives you visual options, such as Dataflow's Gen 2. And that can be really useful for straightforward ingestion and transformation, especially when you want to move quickly. The trade-off appears when the process becomes more dynamic. If I have dozens of source tables and want ingestion driven by metadata, consistently versioned and repeated as an engineering pattern, I'll probably move back toward notebooks and pipelines. So I see Fabric's low-code tools as a useful additional option, rather than something that necessarily replaces engineering code. The difference becomes a little more noticeable when we get to something like entity resolution, candidate generation, phonetic blocking, similarity scoring, tiered decision logic. These are more engineering-heavy workloads, and they're the type of thing you're likely to iterate on quite a lot. That's where Databricks tends to feel more centered around data engineering and machine learning workflows. Fabric can run the same PySpark logic. We've just proved that. So this isn't really a question of capability. It's more about the surrounding engineering experience as workloads become larger and more complex. Governance is another interesting difference. Databricks puts Unity Catalog right at the center of its governance model. That gives you a unified layer for things like data access, lineage, and auditing. And in regulated environments, that becomes very important. Because eventually someone may ask, where did this value come from? Who could access it? Or what transformation changed it? Fabric approaches this from a different direction. You have workspaces, OneLake, Power BI security, and integration with the broader Microsoft governance ecosystem, including Purview. And if your organization already operates heavily inside Microsoft 365, Power BI, and Azure, that integration can be a genuine advantage. So I wouldn't frame this as one platform having governance and the other not. They simply have different centers of gravity. Versus Unity Catalog function. The function we just published is another good example. In Fabric, we used a user data function. That works well when I want to package a relatively small piece of Python logic and allow an external application or workflow to call it. Databricks also has functions through Unity Catalog, but those live closer to the data and query engine, so they're more naturally designed to participate directly in analytical processing. The names sound similar, but they're solving slightly different problems. So rather than asking, which function is better, I'd ask, where does this logic need to run? And how does it need to be consumed? And that brings us to the bigger platform decision. If your organization is already heavily invested in Power BI and wants to move quickly toward governed self-service analytics, Fabric has a very strong story. The integration is tight. The initial setup is relatively simple, and the experience is already familiar to a lot of business users. If the center of gravity is heavier data engineering, more complex pipelines, fine-grained governance, or ML-adjacent workloads like the entity resolution process we just built, Databricks tends to feel more naturally designed around that kind of work. That doesn't mean one platform is universally better than the other. They're optimized around slightly different priorities. And in practice, the answer doesn't necessarily have to be one or the other. For a workload like this, governed ingestion, entity resolution, strong traceability, and a reporting layer that business users actually need to adopt, a hybrid architecture can make a lot of sense. Databricks can handle the heavier engineering, processing, and governance layer. Fabric or Power BI can then sit on top for reporting and self-service analytics. That gives you strong engineering controls where the risk is highest, while still giving business users an environment they already know. The important part is making the boundary between the two platforms clear and keeping the overall architecture governable. So that brings us to the end of the demo. We started with 3 deliberately messy CSV files. We preserved the original data in bronze. We cleaned and validated it in silver. We shaped it into business-ready datasets in gold and used those datasets to build a Power BI dashboard. Then we brought in a completely separate system with no shared customer identifier and used entity resolution to work out which records could safely be connected, which ones should stay separate, and how those matches could be consolidated into traceable golden records. And finally, we looked at how that same type of workload fits across Fabric and Databricks. For me, there are really 3 things worth taking away. First, good data architecture isn't about making messy data disappear. It's about preserving the source, making quality problems visible, and progressively increasing trust in the data. Second, good entity resolution isn't about matching everything. Sometimes the correct answer really is, we don't have enough evidence yet. And third, platform choice should follow the workload. Fabric and Databricks overlap in a lot of areas, but they have different strengths and different centers of gravity. So rather than choosing a platform first and forcing everything into it, start with the engineering, governance, and consumption requirements and work backwards from there. If you're curious what this same solution looks like in Databricks, I've linked another video in the description where I build the Medallion architecture and entity resolution proof of concept end-to-end. Same problem, different platform, and quite a different experience in a few places. And I'd love to know what you're doing in your own environment. Are you using Fabric, Databricks, a bit of both? Or are you still staring at the 2 logos and hoping one of them makes the decision for you? Let me know in the comments. And if you found this walkthrough useful, feel free to like the video and subscribe for more practical content around data architecture, governance, AI, and analytics. Thanks very much for watching, and I'll see you in the next one.